population proportion, usually we use P naught. Okay, in the real situation, we are not able to know population proportion. Okay, so we assume that particular sample proportion as population proportion. So our sample proportion distribution, okay, so there are two conditions. If n is greater than 30, then your sample proportion distribution will be normally distributed. Okay, this one you can read from the one that I've written down to you. Or if n is less than 30, then we have to check if NP greater than 5 and NQ, which is 1 minus P, also greater than 5, then okay. Noah, no one in the waiting room. Why? She's still in where? Rachel, you tell Cindy, there is no one in my waiting room. There's no one in my waiting room. She get into the correct room or not? Okay. So if NP greater than 5 and N, then sample SPR, sample proportion distribution will be normally distributed. Okay. Will be normally distributed. And if you look at the video or the other class, that what we have last Monday, okay, the distribution for sample proportion will be normally distributed. The mean for sample proportion distribution will be equal to the population mean, which is P. So since we don't have the P naught, so we take our one of the sample proportion S. So then the standard deviation will be equal to square root of population standard deviation divided by square root of n. Okay, so that's how you get the formula. You convert it to z-score. Yeah, so you got your lowest and the highest, so it's same thing like the mean. The difference is just the proportion only. So we take the sample proportion as the population proportion. Since we don't have, we take that particular sample proportion as the population proportion. So from here, we got this formula, the predicted, the confidence interval. So we have here P hat plus Z alpha over 2 square root of, since both are square root, so we combine together. Okay, so this formula is also important that you have to write it down, because sometimes you may need to use it to look for the P hat. So you please go through the one that I have put into WhatsApp. Huh?
Is that ZX or like a weird ribbon shape?
Alpha. Okay, are you okay? Okay, then from here we got the sample size formula. Okay, you don't have to memorize it, but You can write it down. So if you want to find the suitable sample size, I give you the width or whatsoever. So this is the formula you're supposed to jot down. So it will be 2 times the Z alpha over 2 divided by the width, the whole thing square, then P 1 minus P. So I've explained in the previous value that if I plot the graph, if I plot a graph of N against P, so P is proportion. So the domain will be between 0 and 1. So when you plot the graph, you find that this is a quadratic equation. Y equal to a constant x 1 minus x square. So you see 1 minus x. So this is a quadratic function. All right. So this quadratic function, you pass through 0, you pass through 1. You pass through 0 and pass through 1. So it's symmetrical along 0.5. So you see, for whatever proportion you give me, proportion of 0.5 will give you the, if P is equal to 0.5, N is maximum. So whenever you want to look for suitable sample size for this case, you can use your P as 0.5. Okay, but if I can have a smaller sample size and have the same result, then why don't I use a smaller sample size? Why must I use the bigger sample size? Waste time, waste energy. So you can choose this. In exam, you choose this, I also will not deduct your mark. So you can have any value. So that means there are 3 choices for your P for this formula. You can use P naught. That means population proportion. But if the population proportion is the outdated one, then I will not use that. Okay? Or you can also use as your P hat. So up to you, 3 can be used in exam. Okay, that's all. Okay. So when you want to explain, when you are writing thing about proportion, correct? You want to explain in your report, then you plot this graph and explain. Why certain situation you use this, why certain situation you use that. You go and give your own reason. Yep. Okay, any question?
Miss,
Okay,
what is A?
Okay. What do you want to ask?
What do you mean by the outcome is the same when you say a
Huh?
P? What do you mean by the outcome is the same when you say P can be 0.5 or P can be the population proportion, all these things? Like, would we change the N?
Okay. If I use this, that one, I put 0.5, I get a bigger sample size. But my outcome will be the same. When I use that, my sample proportion distribution is still will be normally distributed. Our outcome is talking about the shape of normal distribution.
Oh, okay.
With this sample size, with that sample size, I still will get the same, the distribution is still normally distributed. Because if it is not normally distributed, then you cannot use this formula, you know not? You see, very important, huh? So why must we always check this? The reason is because we want to use this formula. If not, then you have to use other type of distribution, chi-distribution and so on. That one we didn't learn. So we state this statement is just to ensure that our sample distribution, whether it's for proportion or mean, is normally distributed. Then only we can apply this formula. This is come from the z-score is from the normal distribution. You get what I mean? So when you write your report, you must say why you need to check that. Because the confidence interval that we find is based on the principle, based on the basis that our sample proportion must be normally distributed when you are using this formula. So this is something that you have to state there. Okay. Yeah. So I want to discuss one of the question. So from now on, I'm going to discuss the question in the textbook. Or you have any specific question you want me to discuss, class? Okay, listen here carefully. Our S86, Okay, let's talk about our S86 first. Yeah, S86. Okay, when you want to have it, tell me. Folio is 31st, S86, when you want to have it?
Miss, it must be this month, right?
September, September cannot, or September is trial. You see, I write down there. I wrote down there 23rd. Okay, this time round, okay, what is the issue? Cannot. 30th too late already. 31st, you are supposed to submit your folio. You tell me the reason why it can be later, have to be later. I give you 2 weeks now. Okay, psychology set when? Then I make it earlier. Then I make it earlier. Okay. If 23rd cannot, 24th, 25th. 25th, what time you tell me? Okay, 25th, what time? You tell me what time? I tell you, I push also 25th what time? I tell you, you push then your folio, I'm not going to push. 25th what time? Okay, 25th what time? You give me the time.
5 p.m.
Sacrifice the lunch time. Okay. Okay, 1 to 2, everyone, no. Got class until 6 p.m. Got class until 5 p.m. Okay lah. So, then at night, we have our SAT at night. Okay. Everyone, you have 1 to 2 got class or not? 1 to 2 got class?
Yes.
Got. So, I told you already, Monday is the best.
Miss
Morning
Do,
lah.
what if we do have the SAT 6 on the 23rd, but we push back the deadline for the folio?
No.
That's okay.
I'm not going to push. Deadline for the folio cannot push. I have less than a month to mark. Do you know that? Mark folio is not like mark exam paper. No, I can sit down there. After I read 5 or 6 copies, I want to warm it already, I tell you. Hello, please tell me. If you want 25th, then how? You want to inject caffeine or whatsoever? I cannot do anything. I tell you. Don't say like that. So 23rd, okay? Everyone, you want to take care of your own. I cannot do anything. I cannot do anything. You cannot do a pool one. You do a pool no way one. Okay, we fix 23rd, 5 to 6:30. You 23rd, 24th also the same thing lah. I'm telling you. You study what is the problem. It's just you write your folio, you also learn already. So what other things you don't know about your SAT 6? You should be very well prepared with your SAT 6. Because you should have a very good understanding of chapter 9. If not, how are you going to write your folio? What do you mean by too early, Emily? What do you mean by too early? You tell me. What do you mean by too early? '30th, then 31st, you pass up your folio. Everyone don't have a class during this time, correct? Do you have a class during this time? No, correct? And you have the weekend to do your revision, correct? So fair. I won't clash with any other subject. Yeah? Like or don't like, this time I'm not going to give in already. Okay, last chance to voice out. Talk, ah. I don't want, I don't want in the chat.
Miss, I propose, I think you should move the maths SAT to 30th. We can still do the folio, like the folio earlier.
Yeah, earlier
But we
than.
are not like waiting for like the 23rd to 25th to do our folio last minute. We're starting our folio now, like you said, this weekend to think of subjects. So
We have
Yeah.
that on the 30th.
we have that on the 30th. I thought it was 31st.
31st is
Laptop's on the
public
30th,
holiday.
and then 31st is a holiday.
Well, never mind, not 30th then.
31st is a holiday, you still have to pass up, ah. I put 31st, ah. It's pass up online is not a problem.
Miss, why can't we do on the 25th for our second class, in our second class?
Can. But online, you tell me how? 1 o'clock, you have the class. 3 o'clock, you have the class. You tell me how? You give me suggestion. You want to have it on the 25th, you give me suggestion. Okay, you give me suggestion. Okay, you want to have it on the 25th? You tell me how to do. At least I need until 2:30, 3:30. You see the way you come into the class and so on. The way you send to me and so on and so forth. You know yourself, 5 SAT already. Still the same story.
Miss, I think what we can do is we do it on the 25th at 2 p.m. And then at 3 p.m., I think Group A for chemistry, Group A chemistry class has chemistry at that time, but we can reason with Miss Hua to push the class to 4 o'clock so that she can teach both classes at the same time. So then we'll
Okay,
have the
what
fifth
subject
for,
is that?
Chemistry, Miss.
Chemistry.
But we can reason with Miss Hua, the chemistry teacher, to push back the
So
class
that
to
means
4 o'clock.
Miss Hua have your chemistry class at 3 o'clock. Is it?
3 to 4 for
3
Group
to
A,
4.
and then 4 to 5 is for Group B. So what I propose is that we push back chemistry Group A class to 4 o'clock so that Miss Hua can teach both classes at the same time.
So Miss Hua can teach until 5 o'clock.
Because our
Yeah,
regular
double
class,
chemistry, is it?
Group A has
Okay,
3 to 4.
by the way, during this time, have you received, you have a compressed lab?
Yeah, we have received that.
You have received, correct? You have compressed lab. So can you come back on time for this one? But for SAT, if you put it on Monday, you should be able to. Correct? Your lab start from 30th? Very funny, I don't know. I was instructed during this whole week. That's why I put the SAT 5 to 6:30. So if you tell me this week got tests, I don't believe lah, because compressed lab, we are not supposed to have tests during the teaching time.
Miss, if 30th cannot, then I just prefer doing it on Monday after class. 23rd.
You can do it on the 24th, 4 to 5:30.
24, 4 to 5:30.
Miss, but I'm not sure, but I have vaccination appointment at 24th. So yeah, I prefer 23rd also. I mean, yeah.
So class, if you say you got compressed lab, I can start at 5:30, we end at 7. You want that? So we stick at 23rd. It doesn't take you much time to learn maths. Okay. So if I put it on 23rd and I put it as just do it lah, okay? Can or not? Even what do you mean by take separately?
I mean, like if they want 24th, I can just have it like separately.
No. I don't want to have two. Okay. 23rd. Once and for all, last test, follow my instruction, can or not?
Okay, Miss.
Huh? Hello? You see, the one you propose really cannot. Yeah? So we just fix this date first. We still got 2 weeks. See how things go. Okay? This one, if you want to put later, I also can put it later. You want to put it at night, I also can put it at night. Okay. So everyone go to page 296. The last page of the textbook. Question 15. Can you please look at question 15? So usually the question is long, huh? So when you write your folio, you always start with the problem. Like question 15, the problem is a community group wants to reduce the speed limit in the residential area to 40 km/h. Okay, a survey which shown that over 50% of all households wish to change the speed limit. Okay. Is required before the council will take action. So now, can you tell me what is the population? Okay, can you tell me the population for this problem? Ashley?
Yes. The population, right?
Yeah, what is the population for this problem? What is the population for this
70
problem?
households in the area.
Yes. Again?
70 households in the area.
70 households in the area. Is that area only consists of 70 households? Ethan, what is the population?
The population is the households in the area, all the households.
Yes. Population is all the household in this community. Am I right? Actually, the 70 household is the sample size. Understand? He said they contact 70 households in the area. I mean, in this community. And 37 say they want the speed limit reduced. So what is the parameter of interest here? What is the parameter of interest here? Ethan Xu. What is the parameter that we are trying to predict? Ethan Xu.
Is it the possible proportion of households that want to change the speed limit?
Yes. Proportion of households that I can say the true population. And to predict the true population proportion of household that want the speed limit reduced. Right? So in this situation, they have collected how many samples? They have collected how many samples?
70.
Nafis?
Never mind.
Yes, miss. What?
They have collected how many samples?
They have one
They have
sample.
collected how many samples in this situation?
One sample.
One sample. Okay. So what is the sample?
70 households in the area.
Okay. That is the sample size. So the sample collected. So when you write your folio, you have to be very clear cut of what is it. Okay, hold on. Okay, so the sample collected is with sample size of, I purposely everything write in words, sample size of 70. So this is your N. And the number of household that want the speed limit reduce is Yeah, Kyrie is what?
Yeah.
Kyrie is, what is the number? And the number of household that want the speed limit reduced is? We use the symbol X to represent it.
Oh,
All right,
Okay.
is equal to,
37.
huh?
37.
37. Okay. So you see, you got a problem. You have to know the population. You have to know the parameter of interest. Then you have to also know, okay, now, can we use the confidence interval? Okay, does it fulfill? Is the sample mean a sample proportion distribution normally distributed? So when you are writing your folio, you have to say all this. This question, that's why through this question I'm teaching you how to write your folio. Now, Gerald, is the sample proportion distribution normally distributed? Yes, why? Why, Gerald? Sample limit? What sample limit? Gerald, what sort of sample limit is that? The sample proportion distribution for this situation is normally distributed. Because Gerald, look here. Okay, tell me the reason. So you know, so you when you write your report, you are writing like that. So the sample proportion distribution for this situation is normally distributed because n is greater than, n is equal to 70 is greater than 30. So according to CLT, then you write down there. Are you okay? So if it's normally distributed, then we can use this formula. You can write down. So we can use this formula to predict the true population proportion according to a certain confidence level. So then you can introduce to people this formula. You see or not? That is how you can write your folio. Then the rest, how you want to explain what is this, then you go and explain. Then you also can say that after you have mixed all this explanation already, then you can use it. We also can use our graphic calculator to count the confidence interval. You see or not? That is how you flow first you create a scenario. Then you define the population in this scenario. Your scenario is always someone claims something or someone want to solve a certain problem. Like this question, they want to solve a problem, whether to reduce the limit or not. And the parameter of interest is as long as the proportion is over 50, then we will reduce. Are you clear? So that is this parameter of interest. You are going to predict the population proportion of household that wanted to the speed limit to reduce. And you get the confidence interval, then from there you make a judgment. Then you want to make the judgment more better or whatsoever, then you can have different samples. Like the one I posed to you, I have discussed with the other class this morning, that we can have a few samples. Then we tabulate. Then we discuss how sample size change the width and so on and so forth. So that is up to you how you want to flow. Are you okay? So now you have an idea how you want to present. Then you talk about bias sample and so on and so forth. You must know where to put in. So I'm not going to plan for you the flow. Each one can have different flow. I can start with my graphic calculator first, technology. Then only I come to this formula. Then I can explain technology will help us to speed up our calculation. But just by using technology without understanding how that program works, it won't give us a deeper understanding of the meaning of confidence interval. So then you can start to explain the theoretical part, but don't be too theoretical. Are you okay? So we are looking for this. We are looking for this. We are looking for central limit theorem, a bit you talk about. We are looking for how you explain 95% confidence level. I'm looking for symbol. I'm looking for judgment. Judgment means the inferential part. If you want to get good grade A, correct? Your inference part, your inferential part must be very good. If you just give me theoretical and just state the confidence interval and just make a simple judgment, correct? The highest I can go give to you is a B. And make sure every symbol that you use is correct. So the inferential part is very important. That means you must create a scenario whereby they let you make a few judgments in the same scenario. That's why I tell you, have your exam earlier, because your exam question, correct, your test, right, I will give you, I even create a scenario whereby I have two different situations. So that will give you some idea. So when you write your folio, you know what to do. Inferential part is very important, especially those who want to get A. Inferential part means you have to make judgment. Based on your confidence interval, you make a judgment. You also make a judgment why this situation I have to have bigger sample size. Why this situation I have to be precise. Means my confidence interval should be narrower. Okay? So we are going into the question area. So construct the 95% confidence interval. You should be able to know how to construct by now. Am I right, everyone? Yeah.
Yep.
Mikia, can I have the answer? Mikia, can I have the answer?
Wait,
The confidence interval for this situation.
low part 50.255.
50.
50.255.
255.
Like you can round it.
Okay. Upper.
Upper is 55.5.
Okay. So explain why the council might not be satisfied by the evidence. You sure? You
Yes.
sure the number you give me is correct?
I did not get that.
Because I look at answer for B, question for B, I know it's something wrong already.
It should be
Mikia.
0.412.
If you are my son, right, Mikia?
Yes.
If you are my son, I tell you, do you know how strict am I?
Very.
I tell you, towards you, I'm very, very lenient. If you are my son, I tell you, I straight away take a cane and I just cane already, I tell you. No second chance. Okay.
Okay.
What do you key in for your X? You tell me, Mikia.
Like I think I forgot something.
You forgot something. You forgot
Yes.
to change the confidence level, or I don't know. Exam you forgot lah. Then your mark also fly lah. Okay. So he said, explain why a counsel might not be satisfied by the evidence. Okay. Because there is a possibility that, the lowest possible proportion of people who want the speed limit reduced is only 41.2%, which is less than 50%, correct?
Yes.
That's why the council might not be satisfied with this evidence. So they might not reduce the what? The
The
speed
confidence
limit.
interval.
Speed limit.
Speed
Yeah,
limit.
because the lowest it can be less than 50%. So the proportion of people who agree to reduce the speed limit can be less than 40% because the lowest possible predicted proportion is 41.2% only. Okay, so that is the council might not. Okay, the council insists that they need a survey will result in a 95% confidence interval of width. Okay, why do you think P * equal to half should be used in estimating the number required to obtain the confidence interval of its width? How many households should be surveyed to ensure? Okay, why? Okay, now let's talk about part C. Why? You use this formula, by the way, 2 times 1.96 over width is 0.05. They ask why we use 0.5 here. Okay. Can someone tell me why we use 0.5? Because in this situation, you don't know.
Because you don't know the population proportion.
Yeah, you don't know the population proportion, and you don't want to use one sample proportion to estimate. So you try to get the as big sample size as possible. And with the 0.5, that will give you the highest sample size. And another thing is because the width is very small. So you only want 5% difference between the highest and the lowest. So that is a very narrow width. So to create this narrow width, the bigger the sample size, the better. All right, so we take a bigger sample size. That is the reason why you say so. Are you okay? So can you use your calculator and calculate? Okay. Okay, if you round up to 3 significant figure, please make sure you always round up. Remember, this one must always round up. Okay. If you don't want, you can round to 1537. Also can. This is 3 significant figure. This is whole number. Okay. The survey to satisfy the council requirement was carried out. And about 52.9% of the households said they were wanted the speed limit to reduce. How should the council react? Okay, now, for part D. For part D, okay. The survey to satisfy the council requirement was carried out, and about 52.9% of the households said they wanted the speed limit reduced. How should the council react? So they have to find the confidence level. So that means if you take the sample size as this, so the n is 1540. So may I know what is the n, what is the x? Can someone tell me what is the x? Hello, what is the x?
804.
Yeah, so what you need to do is
150, I think. Or 40.
150. Yeah. How you know it's
150.
150?
Rounded up.
Yeah, 52.9 divided by 100 times 1540, correct?
Yeah.
So this is the value of x. So you key into the calculator and find the confidence interval and see how it goes. Are you okay? So then you decide how the council should react. You cannot base on that sample proportion and decide. You have to find the predicted true population proportion. Okay? So 815. Is it 815? Approximately. So then you find the confidence interval. This is your x. Okay? Then you explain accordingly. So how should the council react? Can someone give me the confidence interval for this one? Hello?
I got 50.4 as the lower one.
50.4.
Yeah, and then the upper would be 55.4.
Okay. So the lowest possible predicted proportion of people who agree to reduce the speed limit, to reduce the speed limit is 50.4%, which is greater than 50%. So now the council can go ahead and reduce the speed limit. Are you okay? So you create your own scenario. Are you clear?
Yep.
Okay. Okay, now so go through all the questions in the textbook. If anything, you need my help, please let me know. I will try my best to help you. Yep. So from tomorrow onward, that means if you have any of your folio question you want to discuss with me, discuss it in class. Everyone can listen to it. Everyone can learn from that. Okay. Thank you, class.
All right. Thank you, Miss.
Thank you, Miss. Thank you, Miss.
Thank you, Mr.